Alright, today we're looking at here what we call rectangular hyperbola. So, new topic here, other graphs is the topic, should have mentioned that first. So we're just going to look at a few different types of graphs. You know, we've looked at straight line graphs and we've looked at parabolas. So now we're going to look at some other graphs, and while we're looking at that, we're going to look at some commonalities between different types of graphs. Alright, so the first one we're looking at is a rectangular hyperbola. There are two types of hyperbola. One of them's rectangular, the other one's polar. You don't need to worry about the polar form in this course anyway. So just rectangular. So a rectangular hyperbola, if I go to the calculator. So this first one up the top here, we've got y1 is 1 on x. So a rectangular hyperbola has this form. Alright, so rectangular, our basic form is y equals 1 on x. Okay, so that's our basic form of our rectangular hyperbola. And so here it is. Here we've got this particular one here, 1 on x, our basic one. So if we look at the graph of it, I'm going to look at a table of it first. So if I look at the table, so here when x is -5, -0.2 and so on. When x is -2, -0.5. Now you'll notice here at 0 there's an error, so it's 1 on x. So we have this error, and then when x becomes positive, the numbers are there are kind of mirror images almost in a sense of each other. So -0.5 is at -2, 0.5 is at 2. But we've got this error here. So the question is what happens there. Alright, so I'm going to actually then come back and I'm going to draw the graph now. This is what the graph looks like. So it's got this curve here. So rectangular hyperbola, it curves in here using the x and the y axes. Alright, now I mentioned about this point here. So let me bring up something I can draw on. Let's choose colour. So when x was 0, it was undefined. So what we actually have down through here is kind of this line. We have another kind of a line there. Whoops, very straight, unstraight lines I've got there. So we've kind of got these lines where the graph curves in towards. And so these lines where the graph curves in towards are what we call asymptotes. So let me have a look here. Here we go. So as I said, we've got these, and it curves around like this. And so we've got these lines down the middle here. That's called, and this one's vertical asymptote. And then we have this other one across here. This is rough, and this one would be the horizontal one. Alright, so what is about an asymptote? Asymptote, the graph heads towards. Right, so graph heads towards asymptotes, getting closer and closer as we go, which is all very nice. All right, now I'll get back to more on those asymptotes in a minute, but for the moment, what you're going to have a look, you'll perhaps noticed here that I've had in this one, I have this 2 on X. So I'm going to click that and get that to draw that, and so you'll notice we've got something that's happened here. And so what we do is we look at that point, 1, 1, and now we look up here and the point's now 1, 2. So it's kind of like on the blue line, that point's, whoops, that point's moved up there. Now I've got another graphic that shows that. So here we go. fx is just another way of writing y. It's called function notation. We'll get to that at some point this year. All right, so we've got our normal 1 on x. And this 1 here, I can change that by using this blue slider. So to 2, to 3, to 4, to 5. So what you really want to do is you want to look and focus on this point here. And you'll notice that this point, as we slides up, so at the moment it would be 2.5. It's now 2 and 1, 2 and 1.5, 2 and 2. So this is what we refer to as a dilation. All right, so our number up the top, so if we have y equals, and I'm going to call it an a on x, that a there is what we call a dilation, and it's from the x-axis. All right, so I forgot to bring that screen back up, sorry about that. All right, so if I'm going to write it instead of 1 on x, I'm going to change that number and I can make it whatever I like, a on x, and it's a dilation from the x-axis. All right, because the point is moving, it's moving up, but it's moving away from the x-axis as it moves up. All right, now, and this, pick any points in that we're saying. So now the next thing I'm going to look at, so that's dilations. The next thing I'm going to look at is what's called a reflection. All right, so if I change this, there it is back to there, and perhaps I can come back to the Casio, and so I could make another one here, and so keyboard, and I'm going to put, actually I'm going to put a negative in there first, and now I'm going to go 1 on x again. All right, tick that, and now I'm going to graph those. All right, and so have a look at the green one in relation to the blue one. Now, what the convention is here for this, because this fits in with the way other graphs behave as well, is rather than looking across this way, what we're doing is looking this way here, up and down. So it's like the blue one gets flipped down into here, this flipped down into there. So that's what we would refer to. So let's make it -1. There it is. So instead of being up here, it's now down here, and so it's been reflected. And so what is it's reflected in the x-axis. All right, and if you go back to here, for rectangular hyperbola, a reflection in the x-axis and a reflection in the y-axis, that looks the same. All right, so some graphs, reflections in x and y look the same, other graphs they don't. So the convention here is for this one here is we say this is reflection in the x-axis, and it's when we've got negative A on X. And it's this negative here that gives us our reflection in the x-axis. And I forgot to bring that screen back up, and I've just scribbled all over that. All right, so reflection in the x-axis, and it, as I said but didn't show you, it's that minus there that gives us that reflection. All right. Okay, so before I mentioned about the oops, there we go, these asymptotes, the vertical and the horizontal asymptotes. Now, those have been looking, I needed an extra page in there, but anyway, not to worry. You'll have seen this thing, this H and this K. And it's nicely colour-coded here. Pink there and the vertical line, K here and a horizontal line. So if I move this H, and I'll mark H equal to 2 now. And so, you know, when H is equal to 2, you can see their vertical axis. Vertical asymptote, I should say, at 2. So when we have a look at, let me bring up that screen so I can draw on that. So when we've got this thing fx or y, it says it 1x minus 2 is what it says, but when we look here, we've got this h as being plus 2, and it's moved here to plus 2, and there's a minus 2 there. So how does that kind of work? Well, that kind of works in this way here. If x minus 2 is equal to 0, what we then have is we would then have 1 over 0, which is undefined. And if it's undefined, what that leads us to is that for this rectangular hyperbola, we've got an asymptote. So if x equals 2 equals 0, if I then add 2 to both sides, that then x equals 2. So x equals 2, and so there it is there. And so x equals 2 is our vertical asymptote. All right, and similarly, we go back here, I'll move that back to 0. If we have this k, then I'll make that, now that's plus 3, and that just moves it in the direction that we would normally expect. So if I come back here, do it in green because it's in green. So here we've got fx equals 1 on x plus 3. And so this plus 3 here, it moves the graph up. And so here we now have our horizontal asymptote. Whoops, can't spell. Is at y equals 3. All right. Now, something else I didn't mention, but I should have, and I'll mention it now, which relates to these asymptotes. So with this one, if I move this, it's moving it up and down. So moving up and down is called translating, and it's translating in the y direction. If I move this one, it's going left and right, moving left and right, and again this is translating. and it's moving it left and right. So this one here, the one we did before, which was fx equals 1 on x minus 2. So what we have here is we have a translation of 2 units in the positive x direction. Right, and out of that, what that means is that we have a vertical asymptote at x equals 2. All right, so that's all wrapped up with each other. All right, now sometimes you can translate 2 different ways. There we go, look at that. And yeah, let's go to there. And so you can see this one here, we've got some intercepts. So we should always try and find some intercepts if we can. And that will help us with our sketching of the graphs. So let's have a look at some sketching of some graphs now. Let me have a look at an example. Examples I've got in here. So here we go. So sketch a graph of y equals 2 over x plus 1 minus 3. All right, so we can get a couple of things from this straight away before we even go any further. First of all, from the x plus 1, when that equals 0, take 1 from both sides. X would be equal to -1. And so that's our vertical asymptote. All right. We've then got this minus 3 on the end, and that minus 3 on the end is our horizontal asymptote, and that's y equals 3. All right, so if we go over to the next page, I've got some graph paper here. Use the background. There we go. Oh, there we go. Look at that. There we go. All right. So what did I say we've got? We've got a vertical asymptote x equals -1. So down here, at x equals -1, we've got a horizontal asymptote at y equals -3. Oh, nearly got that. See that? It's got a negative there. -3. All right, nearly got that one wrong. So y equals -3, and that's down here, like so. Should label them. Good practice. All right, we've also got, with this one, we've got a dilation. Now, in this particular case, the dilation is going to take care of itself when we find the axes. All right, because we've got a thing that's going to swing around here like so. So we've got some asymptotes that are going to take care of themselves when we find asymptotes. Dilation that's going to take care of itself when we find intercepts. So the y-intercept, x equals 0. So y equals 2 over 0 plus 1 minus 3. 2 minus 3, -1. All right, so we've got intercept there. We now need to look at our x-intercept, and that's when y equals 0. So you've got 0 equals 2 on x plus 1 minus 3. Add 3 to both sides. You get 2 on x plus 1. Times both sides by x plus 1. Cancels there. And then when we multiply that out there, we get 3x plus 3 equals 2. Take 3, whoops, take 3, 2 minus 3 is minus 1. Divide by 3, negative 1/3. Alright, so x-intercept, negative 1/3, just about there. So our rectangular hyperbola swings around there like that. Now this bit that's down over in here, just kind of, you're trying to make it, so if I go across 1 there, I go up 2. So if I go across 1 here, I go down 2 to there. And about there. And so this one kind of swings around like that. Alright, and so there's our graph. So we kind of make these things here, these two look similar. Alright, so there's my, let's go to the next example. Excuse me. So same thing, let's have a look, sketch the graph of it. So again, first of all, straight out, let's look at some asymptotes. There's no number on the end here, so our horizontal asymptote is y equals 0, so where we would normally expect to see it. So let's go and get my graph paper again. So we're expecting our horizontal asymptote there. Alright, our x minus 1, when that equals 0, oops, x minus 1 equals 0, add 1, x equals 1, that's our vertical asymptote. At x equals 1, so let's go and put it in down here. And then we've got a couple other things that have happened here. We've got a reflection, and we've got a dilation. Now when we find out intercepts, that's going to sort itself out. Now with this particular one here, because the x-axis is the horizontal asymptote, along here the x-axis is horizontal asymptote, it's not going to have an x-intercept, but it will have a y-intercept. So y-intercepts when x equals 0, so we've got y equals negative 2 on 0 minus 1, which is negative 2 on negative 1, which is 2. So when we go across to there, we've got an x-intercept, I'll draw these in green, an x-intercept of 2. Alright, so normally, remember, we would expect to see down here, and so we've got that reflection. Alright, I'll leave that in rather than. Alright, so what does this go? This goes around there like that. And so across 1 and up 2, so I've got across 1 and down 2 to there. and the other part of it is going to swing around in there like so. X equals 1 is one asymptote, and y equals 0 is our other. All right, and so there's that graph there. And that's about it for rectangular hyperbolas. So, all right, I nearly forgot to do a little bit of a summary here. So, if we have a rectangular hyperbola in this form, y equals a over x minus h plus k, then we know a few things. So the a, of course, that's our dilation, factor a, from x-axis. And if a negative, what we have is a reflection in the x-axis, and we've got our h and our k, and so we've got a vertical asymptote at x equals h, and we've got a horizontal asymptote at y equals k. So those things will help us when we're sketching, of course, as usual, x-intercepts when y equals 0, and y-intercept when x equals 0 for those things. All right, so that's a nice little summary in your work plan. This is exercise 4A questions, so page 149 onwards, and you're doing question 1 and 2, we're doing them all, and question 4 you're doing every second part. All right. So if you have any issues with that, make sure you ask. And that's rectangular hyperbolas.